and welcome to the Hubble Cast, the podcast that helps you go beyond Earth. I'm Sima Bukhamseen and I'll be your host for this podcast. For today's episode, I'm super excited as I'll be discussing one of the most fascinating objects in our universe, but also the most mysterious. If you haven't guessed already, it's black holes. I'm pretty sure everybody has heard of black holes, thought about them, maybe even dreamt about them. But do you actually know what a black hole is? Well, based on its name, many people assume that black holes are just empty space. But don't let the name fool you. Black holes are anything but empty space. Rather, black holes are a great amount of matter packed into a very small area. Now, by just saying that, it's probably difficult for you to imagine how that would be, so I'm going to try to give you a metaphor. Imagine a star 10 times as big as our sun being crammed into a sphere the size of approximately New York City. Could you just imagine how that would be like? As a result, you would get a gravitational force that is so powerful that even light cannot escape. Now, since ancient times, there has been speculation about the possibility of a vast, dense object in space from which light could not escape. And Einstein's theory of general relativity is most renowned for predicting black holes, actually, as it demonstrated that when a giant star dies, it leaves behind a tiny, dense remnant core. And the calculations demonstrated that if the core's mass is more than roughly 3 times that of the sun, the force of gravity will outweigh all other forces and result in a creation of a black hole. Now, interestingly enough, black holes are invisible to telescopes that search for light, X-rays, or other types of electromagnetic radiation. But by seeing how they affect neighboring matter, we may predict and infer the existence of black holes and even study them. So many people will see photos of black holes online and on the internet and will assume that that's how the black hole would look like to them. But that's actually very far from the truth, as you actually wouldn't be able to see a black hole. It's invisible. But what you can see is how that black hole interacts and interferes with the neighboring matter, which could be light, for example. And you can see what happens to the light as it enters that black hole, and then that's what the pictures are. So if a black hole passes through a cloud of interstellar matter, for example, it will draw inward in a process known as accretion. A normal star may experience similar behavior as it approaches a black hole. So it's definitely a very difficult thing to envision in your head, but it's very cool. Now, in the situation of the star, when the star is being drawn towards the black hole, it may rip and tear apart, and the heated and accelerating matter attracting matter radiates X-rays into space as it accelerates and warms up. And recent findings provide some fascinating evidence that black holes have a profound impact on the area surrounding them, which is pretty much how we study them. And they release strong gamma ray bursts, which devour neighboring stars and stimulate or hinder the birth of new stars, depending on where they are located. However, a lot of people question how black holes are created in the first place, because obviously they have such a huge impact on their surroundings, and they just seem to be this crazy object in our universe. But when you think about it, how are they even created? Well, I'm going to summarize that for you. Most black holes are created from the remains of massive stars that explode in supernovas. Essentially, smaller stars eventually develop into dense neutron stars, which lack the mass necessary to trap light. So, theoretically, it may be demonstrated that no force can prevent the star from collapsing under the pull of gravity if the overall mass of the star is great enough, which is about 3 times the mass of the sun. However, an odd thing happens when the star deteriorates. Time on the star slows down in relation to time maintained by the observers far away. And when the star's surface approaches an imagined surface known as the event horizon, time stops when the surface hits the event horizon, and the star can no longer collapse. So it's essentially a frozen, collapsing object. Isn't that just mind-boggling? Now, stellar collisions may produce much larger black holes. SWIFT, a telescope operated by NASA, started observing gamma-ray bursts not long after its launch in December 2004. And after NASA's Hubble Space Telescope acquired data from the event's afterglow, as it is called, astronomers came to the conclusion that strong explosions may happen when a black hole and a neutron star meet, creating another black hole. So that really allows your imagination to run wild as to how these black holes are created. And although the basic formation process is understood, it's still a mystery why they seem to exist on 2 dramatically different size scales. Because a lot of people think that black holes are all the same size, but that is very untrue. Black holes come in a lot of different sizes. Numerous black holes that are the remains of huge stars may be found on one end of the spectrum. These stellar mass black holes, which are scattered across the universe, are typically 10 to 24 times as massive as the sun. And when another star gets close for some of the material around it to be drawn into the black hole by its gravity and produces X-rays as a result, most stellar black holes, however, are very difficult to detect. Judging from the number of stars large enough to produce such black holes, however, scientists estimate that there are as many as 10 billion to a billion such black holes in the Milky Way alone. So that's just one end of the spectrum. However, the supermassive black holes, which are millions or even billions of times as massive as the sun, are giants at the other extreme of the size range. Supermassive black holes are thought to be at the heart of almost all major galaxies, including the Milky Way, which is where we are. By keeping an eye on their impacts on neighboring stars and gas, astronomers can spot them. So it's definitely very interesting to see the wide range of sizes that these black holes can come from and how they're made. It's definitely something that I've always been interested in, and I really wanted this episode to kind of compact everything I've learned about them and just deliver it in a very simple manner. And just like that, we have reached the end of today's episode. I really hope that this episode helped you understand the basics of black holes. They're obviously such a fascinating phenomena in our universe, but they're so difficult to comprehend because they bend the laws of physics that we understand and apply to our day-to-day life, Especially when it comes to the time and the dimension, it's really difficult to comprehend and understand such an idea. They're very interesting, but definitely something that takes a lot of effort to understand and comprehend. But regardless of that, I hope you enjoyed this episode nonetheless, and make sure to stay tuned for future episodes. Goodbye!